Hello everyone, my name is Alan Dodd. I'm a vegetation ecologist and the owner of Longview Ecological, based in Calgary, Alberta. Today I'll be discussing the results of some work we did for the State of Calgary's riparian monitoring program with respect to herbaceous seeding monitoring and analysis. Here's a quick agenda for my presentation. I'll start off with a bit of background information on herbaceous seeding. Next, I'll briefly discuss the methods we used, and then I'll present some of the findings arising from the project, and then I'll finish with some recommendations for future projects. So what do we mean by herbaceous seeding, and why do we care about it in bioengineering projects? The word herb is a botanical term that refers to non-woody species, which includes graminoids, which are your grasses, sedges, bulrushes, that kind of thing, as well as forbs, which are your broadleaf plants, sometimes referred to as perennials or wildflowers. And graminoids and forbs are often seeded on bioengineering projects to provide early ground cover while your important woody vegetation is establishing. And this early ground cover helps to minimize soil erosion, provide soil stability, and also enhances biodiversity. And these herbaceous species can be seeded using several different methods, which I'll talk about in a bit. In terms of methods, so data for the RMPA project was collected over a 5-year period from 2018 to 2022. A total of 69 bioengineering sites were visited. At each of these sites, pinpoint transects and 1 meter squared quadrats were assessed within each bioengineering technique. So that's things like live staking, brush layers, brush mattresses, etc. And data from both the transects and quadrats was used to confirm the presence of seeded herbaceous species, while the transect data was also used to analyze how well the species performed as measured by percent ground cover. And importantly, the data collected includes a time series component, which allowed us to look at how well individual species performed after 1 year as well as after 3 years and 5+ years. Sufficient data was available to conduct an analysis on which application methods produced the best results as well. Well, in total, we had 85 transects and 255 quadrats in which to analyze. And in total, we had about 54 different herbaceous species that had been seeded on those 69 sites that we looked at. So this presentation will focus on the results for the native herbaceous species as opposed to non-native species. Generally speaking, the majority of seeding applications we analyzed did use native species, which is great because, we want to promote the use of native species due to their importance to local ecosystems as well as their adaptations to local climate. Non-native species were used in some instances and generally performed well, but these species should be discouraged from use in future bioengineering projects. They're not from this area. So this first table shows some of the better performing native grasses that have been used on successful Calgary bioengineering projects. The different species are listed on the left. The column to the right shows the sample size or number of transects on which the species was seeded. The third column, success rate, refers to the percentage of sites where the species was seeded and then subsequently found. So for example, if a species was seeded on 3 sites or 3 transects and we found it on 2, then the success rate would be 67%. And then the last column shows mean percent cover, which is a measure of how abundant the species were on the sites where they were found. So the higher the number, the greater proportion of ground covered. The 7 top performing native grass species are listed here. So we have slender wheatgrass, foul bluegrass, Canada wild rye, northern wheatgrass, western wheatgrass, green needlegrass, and tufted hairgrass. These 7 species all perform quite well, both in terms of successful germination as well as providing decent ground cover. Slender wheatgrass in particular had, 90% seeding, over 90% seeding success and almost 40% cover value. All 7 of these species are highly recommended for future bioengineering projects in Calgary. Nevertheless, it's interesting to note that even for these top performing grass species, only 4 were found at 50% or greater of the sites that were seeded. So even these top performers only succeed in establishing about half of the time. And really, that's partly due to the fickle nature of native species, but it could also be a result of not following seeding best practices. This next slide shows some of the grass species that have not shown good establishment success on Calgary bioengineering projects. So columns are the same as the previous table. Included here are some of the underperforming grasses that also had larger sample sizes. As you can see, a number of species like rough fescue, foul mangrass, blue joint, wire rush, they had decent sample sizes but really poor germination and establishment success. These species were never found where they were supposed to have been seeded. Sample sizes for two of the other ones at the bottom there, Indian ricegrass and sandberg bluegrass, were a little smaller, but still, very poor success. June grass at the bottom, it's a very interesting example, an example. It's commonly included in seed mixes in the city here, but it only has about a 9% success rate and generally very low percent cover there, 4%. The low cover may partly be due to it generally being a small component of seed mixes, like less than 5% or so, but this low establishment success really suggests that there might be better grass options out there. And what these results show is the grass species that should probably be avoided in future seed mixes on bioengineering projects in Calgary. Native seed's expensive, right? And if we can avoid seeding species that are not even getting established, then we might find some cost savings. And conversely, if we focus on seeding native species that are known to establish well, project success could be improved in that regard. I should note one other thing. This is far from comprehensive, this list here of underperforming species. There's a number of other species as well, but a lot of these had small sample sizes like n equals 1 or n equals 2. So species like common tall mannagrass, western porcupine grass, hairy wild rye, fringe brome, northern wheatgrass, these species also did really poorly, but they had a little smaller sample size. And indeed, really, more than half, or 31 of the 54 species that have been seeded along Calgary bioengineering projects, they were never observed by us during our monitoring work, meaning they likely never established. So more than half, that's pretty high. This next slide shows some of the forb species from herbaceous seed mixes that we were able to analyze. As you can see, sample sizes are generally quite a bit smaller for forbs than for grasses. This is because most seed mixes used on past bioengineering projects were mostly comprised of grass species. That's simple fact. And historically, just forbs are much less common in seed mixes in general in Calgary here, and generally only a few species have been included. Nevertheless, including forbs in your seed mix is a recommended practice as they help improve biodiversity, pollinator habitat, plant structure, that kind of thing. I don't have time to go into these results too much, but you can see kind of mixed results here with the top performer being a wild blue flax. Moving on from individual species, this slide looks at seeding application method. Generally speaking, three main types of seeding application method are used on bioengineering projects. Here in Calgary, we have broadcast seeding, drill seeding, and hydro seeding. Broadcast seeding refers to seeding by hand or with a small handheld mechanical spreader. Drill seeding refers to the use of a mechanical seed drill. And hydro seeding is when herbaceous seed is mixed with water and other ingredients such as mulch and then sprayed onto the site with a hose. Success rate here on the left is the same as before and refers to the percentage of species that were seeded according to the seed mix specifications and then subsequently found by us during our monitoring work. As you can see, success rate was 36% for broadcast seeding, 31% for hydro seeding, and 42% for drill seeding. The little A behind each percentage means that there was no statistically significant difference between the different application methods. So, the raw percentages is a little different, but they're not statistically significantly different. It's also important to note the sample sizes, which were generally good for broadcast seeding and hydro seeding, but a little low for drill seeding there at n equals 4. So in addition to the statistical analyses we performed, we also made a number of incidental site observations while we were on site. For example, we observed that some sites had issues with thick herbaceous cover that was outcompeting or even killing the planted woody vegetation. We also observed numerous instances of damage and death of planted woody vegetation from weed whackers, which are often used to, knock back your herbaceous vegetation and weeds. Related to the first point, there were some instances of super heavy seeding application rates, which resulted in thicker than desired herbaceous vegetation cover. Also, in general, seed mixes on the sites we looked at just didn't do that well in terms of establishing and providing early ground cover. And lastly, in some cases, non-native species were prescribed in these seed mixes when native species are generally preferred. Lastly, I'd like to conclude with some recommendations we developed as a result of our monitoring work. I guess the first and most obvious recommendation is, avoid using seeding species that are not likely to establish. So this will hopefully save time and wasted effort. One of the important findings from the RMP project in general, as Mike, I believe, is discussing today, was an issue with compacted soils on bioengineering sites. And just, in general, decompacting soils prior to planting and seeding will definitely help your vegetation establish and thrive. It's also important to ensure that herbaceous seed is applied underneath the erosion control matting to ensure proper soil seed contact. Another observation from our work was a lack of understanding in some cases of how to properly calculate and apply the correct seeding rate. So just ensuring contractors are able to do this is super important. As I mentioned earlier, mowing activities to control herbaceous species and weeds often results in damage to planted woody vegetation. Mowing is also going to kill your native herbaceous species and promote the growth of non-native species. So my sincere hope is that we come up with alternatives to weed whackers for future bioengineering project weed control work. And indeed, the main focus should be on removing any herbaceous vegetation, whether native or otherwise, that's found to be competing with your planted woody vegetation, not just doing a blanket mow down and then specifically targeting your weeds for control. Also, I don't personally have a lot of experience with this, but some scientific literature suggests that soaking your seeds in something called plant growth regulators, which are essentially commercially available chemicals that increase hormonal activity, improve seed germination. These will help your native herbaceous species establish, basically by breaking seed dormancy, improving seedling emergence, and increasing shoot lengths. Next is to follow seeding best practices, some of which are listed here. It's not as far from comprehensive, but these are the main ones, I think. Best practices include things like obtaining and reviewing seed certificates for your seed mix, which allows you to check for weed species as well as germination rates. Also, it's important to seed only in the spring or fall. Summer seeding should be avoided because it doesn't provide enough time for your native species to establish their deep root systems. It's also important to select the appropriate species, which can mean species with proven track records, as I've talked about here, or focusing just on native species in general that you have other experience with that when they do well. It's also important to seed with an appropriate application rate, as I've talked about. Fencing off your bioengineering site while the seed and wood vegetation establishes will also help improve your chances of success. And then lastly, native species don't need to be irrigated to establish successfully, but if you have the means, irrigation could help, particularly, if you have like a dry spring or summer. So if you can irrigate, it'll definitely help things out. And that concludes my presentation. Thank you for listening.